in the original Pong, the first player to reach 11 points wins. In addition to that constant, we also had constants for the position on the screen where we will display the scores. So let's add those to the constant sections of our code right here after max angle. So I'm going to say, okay, the max score is going to be 11. Our score position in X in Y is going to be 30 pixels from the top of the screen, and then we're going to say the score position on the left is a quarter of the window width, putting it smack in the center of the left half, and then the score pos right is the window width, and there's a typo, times 3/4, which puts it smack in the center of the right half of the screen, and there is a T missing right there. Okay, so we have that, and then just where we start initializing things. So these are all the constants, right? So, and then down here, just after the initialization of the game state, we initialize both of our scores to 0. So we call left score equal to 0 and right score equal to 0. So now we need to prepare to actually display the game over message as well. So displaying text in Pygame is more complicated than drawing rectangles. The text needs to be rendered from the mathematical description of its font to pixels on a Pygame surface. That surface will not be the display surface, but rather a container for the rendered pixels. So, and let's start with the game over message here. So, because the contents and position is going to be constant. So let's go ahead and create that. It's a constant, but we in order to render fonts, we have to have Pygame initialized. So we can do that just right here after Pygame init before we get the clock. So we're going to retrieve the font. So the font is going to be Pygame font. That's going to be a font with the with the name free for free type some so it's going to sans serif font, and it's going to be in bold, and it's a true type font. So .ttf. This is a font that's available on any system that's out there. And we want to have this in 24 points. So, and now we have our game over surface that we have to create by rendering the font. So, in the game over surface is going to render the font. So font dot render. We want to have the text that we render, so this is game, and then I'm going to add 5 spaces here, 1, 2, 3, 4, 5, over, and then we're going to have this thing visible, so I'm going to pass it a true for now, and then the color will be white. So the 5 spaces in the message string are simply there to avoid interference on the net with the text. So it does an offset so that the net goes right through that blank space. So, and in order to place the text on the screen, then we have to give it the coordinates. So let's do this. And that's we need a rectangle to display that, and we need basically the boundary rectangle around the rendered text, which there is a call for that's called get rect. So let's do this next. So that's here. So that's the game over rectangle, and we're gonna get that from the surface by saying game over surface dot get rect. So, and then now that we have the rectangle, placing it in the center of the screen is simple. So we can say game over rect. Oops, there's a dot center is equal to the tuple now of window width divided by 2 and window height divided by 2. So that's the preparation of our pixels. So we have a surface to hold the pixel, we have a rectangle to place those pixels on the stream. So let's display that message, and we're just going to do this just before the display update. So let's go down here, right there, and we only have to display the message if the game is actually in the game over state. So I'm going to do this here. If game state is equal to game over, then we will do the following, and I'm going to explain this in a minute. So we're going to display, I'm going to just take the display surface and blit the game over surface onto it. So game over surface, and we need a position for that, and that's going to be the game over rect. Okay, so what does blit mean? The word blit is short for block image transfer, and in the early days of video games, graphic systems had a special chip that could take a bunch of pixels, like our game over surface. Sometimes they're being referred to as sprites, and very quickly and efficiently inserted into the graphics memory at any given position. So the graphics memory is represented by a display surface. The position is represented by our game over rect. These chips were called then consequently blitters, and the name stuck. Graphics cards to this day have special memory areas for storing sprites and still have special commands for blitting. Running the game now will display the game over message as a startup, and once the game is started, the message disappears. So at this time, we'll never see the message again, as the game over state can only be reached by scoring 11 points, which we haven't implemented yet. So let's go ahead, however, and run this just to test our code. So here you see the game over message, and when I start the game, that message should go away, and we'll see the game progressing. So again, we're not going to get the game over message back yet. Okay, so now we need to keep track of the score. So keeping track of the score is straightforward. We simply need to add the code that we're going to now when we check for ball collisions with the boundaries. So, and however, we want to make sure that we want to add this just after the game state is set equal to game stop, and just before we reset the ball to the ball center. So, and that's going to happen right here. So if ball collide rect left boundary, or ball collide rect right boundary, so that's happening just here. So after game stop, and before we reset the ball to the center, I'm going to say if ball collide rect left boundary, then we know that the right player has scored a point. Right score plus equals 1, so we increment this by 1. If ball collide rect right boundary, then the left player has scored a point. So, and now we have to check whether we've achieved maximum score, and then the game is over. So if the left score is equal to max score, or the right score is equal to max score, then we enter the game over state. So, relatively straightforward. That allows us to enter the game over state. Once we're in the game over state, now that we have scoring, when the game is back on, we need to reset the score. So that just goes just before the transition to the game on state. So, and that's happening in our key presses. So that is just right here when we come from here. So we picked up ball speed. We're about to transition to the game on, but if the state we come from right now, the state can be either game over or game stop. We only need to reset it when we are in the game over state. So we're going to reset the score here and then say if game state is equal to game over, then we know we have to reset the score. So left score equals 0 and right score equals 0. So that's the handling of the score. So now we have the score. All we have to do is get the game score on the screen. Again, we do this by blitting. But it's a little bit more complicated now because now the text that we're blitting is not constant, right? It's dependent on the score. So so that's what's happening here now. So before we actually blit it, but just after we draw all of our rectangles, let's go ahead and add the code for blitting it. So this is a little bit more complicated. So we have to basically take first of all, the number that is represented by a score and convert it to a string of characters representing that score, so the actual numbers, and then we have to render that and then blit that. So not super complicated, but nevertheless, so here's how this goes. So left score surface is equal to rendering our font. We're going to use the same font. And then here's how we convert in Python 3 a number to a text. We have a nice little formatting utility that allows us to format strings according to anything we want. So here we've given it a format string, which is given in curly braces here. And then I'm going to say, okay, we're going to basically have a minimalistic amount of characters that we want to represent in decimal. So that's where the D comes from. And so that's that. So that's our format string. And then we plug in a number by telling this thing to format it with a number. And that number is our left score. So that's how we get the string of characters that we render from the number. Again, we're going to make this visible, and we're going to do this in white. So the same thing for the right surface, of course, right? So right score surface is equal to font render. Again, same format string as a decimal number. And I'll format the right score here. Okay, now the rectangles. So I'm going to have the left score rectangle, which is the left score surface get rect, and then right score rect equals right score surface get rect. Okay, set these to the score positions. So we've already defined those. We have our left score rect center. We'll set that to the tuple of the score pos left and the score pos y. And then I'll have the right score, same thing. And then this is going to be score pos left and score pos right and score pos y. And now we're ready to blit. So I'm going to blit this onto our display surface. And I'm going to take the left score surface and the left score rect, and then we're going to blit the other one as well. Right score surface and the right score rect. So that's it. That's the finished game. Let's see whether this works. So I'm going to run this, and we should see a typo. So surfair instead of surface. So line 217. So that is right here. So that's that. Okay, let's run this again. Classic. Oh, and we haven't defined our score positions. So we either forget that or we have a typo in there as well. Let's go back to our constant section and see whether we actually forgot it or not. Score plus y, score plus left. Oh, there is the typo. This is score pos right. So yet another typo. Run this again, and hopefully that's the last one of those. And there we go. So we do have our score. The game is in the game over state. So now we actually see that indeed the score keeping seems to work. The score goes up as the balls are being served. So here you can now see also that the random choice of the direction actually works. Right, so and that is it. We've reached 11 points. The game is over, and we are done, and we can start the game over again with any key. So, game is finished. We have written a full-blown Pong clone in Python and Pygame, and let us just check and what the number of lines of code is. So this is 227 lines of code, so not bad. Congratulations, we've created a classic video game.